Hey everybody, this video is about drag force. So I just wrote the formula already right here. So it looks like this. And you can see that it's a function of a few things. Something called the drag coefficient, the density of the fluid, so like if you're going through air, the density of the air, the cross-sectional area of whatever object is moving, and then the speed at which it's moving. So let me just show examples. So let's say there's a mass transit system, like a train, that looks like just rectangular like this, right? So, and it's going this way. And then let me draw the same, but let me modify the front of it to look more like this. Okay, so let's say from the front, it looks like this, and from the front, it looks like this, and they have the same area. But see, the shape is different. So although they have the same area, they would have different drag coefficients. And this is something determined experimentally. So you'd have to run like wind tunnel tests to kind of measure the drag coefficient. Okay, and then density is, like, why do airplanes fly up at 30,000 feet? Because there's less pressure and then less density of the air. And so if the density is lower, right, then this is lower. Or for example, if I put this mass transit system in a tunnel, like the Hyperloop, I put this in a tunnel, and then I try and pull a vacuum in here to try to lower the density by pulling a vacuum, because there are less air molecules to bang into. Right, so I pull a vacuum, I reduce this. So then there would be less drag force. Okay, or let's say, like I used to ride my bicycle to work for years. I used to live 10 miles away from work, and then I would just bike 20-mile round trip 5 days a week. So 100 miles a week. That's a pretty good reduction of my carbon footprint and good exercise. So let's say you ride your bike like this at 5 miles per hour. What happens if you try and go, right? So let's say you're pedaling at 70 RPM, going 5 miles per hour, and then you speed up, shift gears, still pedaling at 70 RPM, but now you're going 15 miles per hour. What's the difference? Like, it's way harder to go 15 miles per hour, right? That's 3 times the speed. So it feels good because there's more wind on your face cooling you down, but 3 times the speed squared. So there's 9 times the drag, right? Because it's speed squared. So similar, like if you're driving your car, like the faster you go, the more drag there is, but speed squared. So it'd be best if everyone were driving kind of slower at a constant speed. That minimizes the amount of force required to propel yourself, because then you minimize drag. And then also, why do cyclists do stuff like, and so let me some space. You kind of ride like this. Right? So like you're reducing this cross-sectional area. Right? So for the same amount of density and speed, you reduce your area, you try and make yourself as small as possible, and then that'll reduce the drag as well. Okay, so I hope those few examples make a little more sense out of these variables. And for the most part, we won't consider drag too much in this class, but it is important practically, especially like if you're designing wind turbines, like this is a major issue, drag. And then if you're designing cars, mass transit systems, this is a big consideration. Okay, so let me know if you have any other questions. I'll see you in the next video.